Well, in this video we are going to discuss the concept of slope and then the derivative. So starting from slope, what do we mean by a slope? Slope means that if there is one unit change in independent variable, then what will be the responsive change in the dependent variable? This is determined by the concept of slope. So slope means the change in dependent variable per unit change in independent variable, or we can say that change in dependent variable when the independent variable is changed by 1 unit. To be more mathematical, if y is the function of x, which means that if y depends upon x, then if there is 1 unit change in x, what will be the change in y? This will be determined by slope. Alright. Slope is normally calculated by the simple formula, that is rise over run, that is change in perpendicular divided by change in base. Mathematically it can be written as, by rise we mean vertical axis, that is y2 minus y1, change in dependent variable or change in y axis, divided by run means change in x axis or change in independent variable. So it can further be simplified as change in y divided by change in x. What does this mean? So to understand this, let us take an example. So for example, y is dependent variable, which is marks, and x is independent variable, which is study hours. When study hour is equal to 2, marks obtained is 12. But when we increase study hours from 2 to 3 by 1 hour, marks increase from 12 to 18. So clearly this is y, your dependent variable, and this is x, your independent variable. First independent variable changes, then in response your dependent variable also changes. First of all, you have to increase your study hours, then it will increase your marks. So to calculate slope in this case, this is equal to change in y, current y minus previous y, divided by current x minus previous x. So this is equal to 6 divided by 1, or this is equal to 6. So it means this slope is equal to 6. What does this mean? It means that if there is 1 hour increase in your study hours, there will be 6 marks increase in your marks. But it should be noted that slope doesn't have always positive sign. It may have negative sign or it may have positive sign. When it has positive sign, it means that there is a positive relationship between study hours and marks. However, if there is negative sign of the slope, which means that if there is increase in independent variable, there will be decrease in. Before further discussion, you guys are requested to like this video, subscribe to Shah Academy, and press the bell icon to get regular updates of this channel. Dependent variable. So slope can both either be negative or be positive. But again, there is one issue with this formula, because this formula is normally used for straight line, if it is a straight line. But if the relationship between dependent and independent variable is not a straight line, that it is a curved or zigzag line, then you cannot apply this formula. In that case, if you apply this formula, you will do certain errors. For example, if this is the graph which shows the relationship between x and y. Now look, if this is one point and this is the second point, now if this is the graph, for example, which is not a linear curve, a linear line, when the value of x is x1, the value of y is y1, and when the value of x increases from x1 to x2, the value of y increases from y1 to y2. If you want to apply the same formula on this, for example, if we apply slope is equal to change in y divided by change in x, though this is not a linear line, we will commit this much error, and which must be reduced, which must be minimized. So how would we come over this issue? we have to minimize this error or we have to eliminate it. So if we think about it, the one way we can minimize this error is to decrease this interval. For example, if we decreases the interval from x1 to x2 prime, then look at it. Now you can see the error has been minimized by this area. Look at this, by this area. And now the error remains as this much, right? This area. Okay. Now, so long as this straight line intersects this curved line at 2 points, this is called secant. So again, this is a secant. The first straight line is a secant. Now again, these 2 points, this straight line is also a secant. But when we minimize the area from x1 to x2 prime and we reduce the interval by this much, look at it. Now the error has been this much only. So we have found a way how can we minimize this error. So again, we can narrow down the range of x. So again, if we reduce x2 prime to x2 double prime, we can further minimize the error. Now look at it. We have further reduced the interval from x1 x2 prime to x1 x2 double prime, and now you can see the green area is the error only. So if we do the same practice again and again, and so that restrict the interval between x1 and x2 pretty close to each other, then again this tangent would become secant. It will touch the graph at one point, right? And it will be something like this. Look at it. We then further minimize the range by this much, and then we can further restrict it. So mathematically this whole process can be reported as, we can take limit change in x tends to 0, change in x tends to 0. It means that initially change in x was from x1 to x2, then change in x was restricted to x1 to x2 prime, then change in x was restricted to from x1 to x2 prime to x1 to x2 double prime, and now your x2 is pretty close to x1, so that if we join the 2 points, this line joins the 2 points which are pretty close to each other, such that this straight line touch the whole graph. This graph is the function of x on a single point. Why? Because x1 and x2 is so close to each other that their difference tends to 0. And if you apply the same formula, change in y divided by change in x, then it converges to dy by dx, which is the derivative of the function, and this is equal to tangent. By tangent we mean at a straight line which touches the graph at a single point. Why? And this tangent is nothing else, this is derivative of the function. This is the tangent and this is nothing else, this is dy by dx. The beauty of derivative is that you can quite easily point out the derivative at each point on a particular graph. You can find the slope of the function at this point, at each and every point you can point. You can quite easily quantify the slope of the function at any point. And this is used when the slope of the function varies from point to point. If you look at this point, here the tangent is steeper, but if you draw a tangent over here, it will be flatter. So it means that here the derivative will be, the slope of the function is low, here the slope of the function is higher, and here the slope of the function is 0, because if you draw a tangent over here, it will be a straight line. So that's why derivative is normally used when the graph is not linear, where the slope varies from point to point, and if you want to find out the slope of the function at any point, you can use derivatives.